My dear ladies and gentlemen, welcome to the Masterclass Mondays. This is already our sixth episode, and today we will be talking about the device integration, or how to exchange data. Embedded Wizard is the GUI solution by Terra Systems. My name is Kristin and I'm responsible for marketing and communications. Today we will be having a recording as well, so no need to worry. If you want to repeat anything, there will be a recording available on our website for you later. Manuel Milic, our product manager, will today guide you again through our topic. So Manuel, the stage is yours.
Yeah, Christine, thank you very much for the pleasant introduction. Good morning, good afternoon, good evening to all our attendees worldwide. It's really a pleasure now to have you in this sixth episode of the Masterclass Mondays, and I have to admit that today's topic is a topic which was required and requested quite a couple of times. Today we are talking about the device integration, as Christine already mentioned, or how to exchange the data from the GUI to the underlying world, to your middleware, to your business logic. So what are the topics that we will discover in today's session? First of all, I give you an introduction how to do this from a technology point of view, and there the most important key player is the so-called native statement. This one belongs to the Cora language. I'll show you how to do that. Having that in place, then you need somehow to define the interface that you're doing with Embedded Wizard in order to address the aspects of your other components. And for that, I'll give you a short introduction about the so-called device interface. Next to that device interface, which is just one part, we also need now to connect something from your C++ code to the GUI, and that's the case why I have now mentioned here the so-called device driver template. So, but before we get now started inside the studio or inside the other aspects, I give you a short introduction where we are now in this overall architecture. So, in fact, what we have is the main application, of course, which initialize everything. So that means the GUI, your middleware, BSP, RTOS, SDK, etc. Something like we call it the glue layer that binds everything together. In fact, that is the GUI, but this is, from what we are now talking about, only the generated sources, including the platform package, as you perhaps remember from our last week's session. The GUI itself, this also comes with the so-called device interface. Then, depending on your device interface, you also need to do some kind of middleware layer. We call it device driver, which is the adaptation from your customer specific middleware to the upperlaying GUI itself. As you can see, with that approach, we do not enforce our customers to follow our API in order to integrate their customer-specific middleware, their customer-specific business logic into the GUI world. It's the other way around. We enable customers in order to implement their own API according to their needs. And that being said, we do also not enforce to say, okay, it's only a synchronous API, it's only an asynchronous API, it's something like a message-based API or event-based API. In fact, you can do whatever you would like to do. This is, of course, benefits, but on the other side as well as disadvantages. Benefits, so the pros are that you can, of course, define your own API that fits to your dedicated middleware. In fact, when you already have a dedicated business logic middleware in place, which takes care about doing what your appliance should do, then it's very easy just to do some kind of adaptation on top of that and then bring it to the GUI world. On the other side, that gives you a lot of freedom, and giving a lot of freedom could also be that this will give you, in the first, when you're dealing with this in the first time, that this also gives you a more complex way of how to do that. It's not very straightforward because there is no API. You need to define your own API that should be used inside Embedded Wizard. That being said, it's also important to know that, yeah, from the GUI point of view as well as the device driver, yeah, you can do whatever you would like to do. So let's get started and get some hands-on how this could look like with Embedded Wizard. Today, just before starting now or to creating a project, I'd like to say that today I have also attached a small board to my computer here, which is from NXP, the iDynamics RT, sorry, where is it? iDynamics RT 1060 evaluation board. And this one is now used for our masterclass episode 06 project. So, and that means that for the profile, we already have set up the proper platform package, as you remember from last week's session, and also the screen size is already predefined in a proper way. So, going to the application, we have a very simple one. I think that is something that we can remove, just hitting delete key on my keyboard, and we have a just very, very black and simple rectangle there. So that device that I have attached, I will show you a live stream, a webcam stream later on, how this really works in real life. Does come with an LED on board. And this is something that I'd like now to use inside my GUI. So that means I need to have, first of all, something to enable that LED, and for that I'm using a very simple push button there, and just move it to the center of the screen and say, okay, this is my toggle LED button. Very simple one. Pressing play, it works as usual, as expected, and that's it. So adding that toggle LED, this should now invoke something. And how do I now enable my on-chips available LED in a proper way? To do that, as you remember, the switch button, or the button itself, comes with a possibility to assign dedicated slot methods. And this is now something that we are doing as well. So just opening the Cora in gallery and drag and drop the slot method, and there we say, let's toggle our LED. Very simple one. This one selected there, and assigning that now to my widget, while we say, okay, on activate, let's toggle my LED. So double click on that slot, opens the editor, and then we have now the Cora statement there, or the editor of Cora, what can be done. First of all, just making sure that, not trace, that everything is set up, and we say, okay, let's toggle the LED right now. Starting the prototyper, going to debug, open the prototyper, switch the button there, and you see the connection works. The button works, and the connection now to the slot method works as well. Okay, so this is all fine. This is all set. So how now do I enable, or how do I now toggle the LED itself? To do that, I need to have some kind of API. Something that I also would like to mention is that when just, sorry for switching, but just going back now to the architecture point of view, something which is really important, that we suggest our customers to really take care about a proper separation of the dedicated concerns. So that means the GUI layer should take care about the GUI, whereas the middleware, the business logic, this should take care about all dedicated customer specific parts. For example, that means if you have a GPIO that needs to switch on a valve, that needs to switch on an LED or get the user input whatsoever, that you do not do a direct addressing of the GPIO inside the GUI layer. This is, from an architectural point of view, not the best choice. It could be that it works, of course, but we suggest really to define your logic inside that middleware layer. So that means if you have some kind of, let's say, coffee machine, and you want to brew the coffee, that means that you need to switch on a valve and a pump, something like that, that you just say, okay, not switch on pump or switch on valve or whatsoever, that you say brew coffee, and take this into account from a logical point of view, and define a proper API that is then propagated to the GUI layer. So that means inside the GUI layer you do not then toggle the GPIOs. Now this is something where the middleware is taken care about, and you define the proper API that needs then to be used by the GUI. And with that, you have proper separations, and this gives the big benefit that you, for example, can also run a proper test on dedicated parts. So that means you can really do a proper testing of your middleware aspects, that the brewing process is done without any UI, and you can also test then later on the GUI by just replacing the middleware component with a let's say simulated middleware component, which is dedicated to the test cases that you're doing within the GUI perspective. Okay, so just a very small excursus about separations of concern and architecture and how to do things. However, now in this example, I'm now going to break this rule in order just to show you how to deal with switching on the simple LED. So where now do I have this LED API defined, how to use it? And for that, just minimizing the Windows there. I said I have now connected an iDynamics RT1060 evaluation board now to my system, and I'm also using the build environment. Just a cross-link to our previous webinar episode where I talked about also the build environments, and this is something that I'm now using, of course. Inside that build environment, there you see inside this target specific folder a dedicated module called ewbsp in.out.h and .c file. So C is just the implementation that we will look later on perhaps, but what's now most interesting is this ewbsp in.out.h file, which comes with a proper method called ewbsp in.out LED on as well as ewbsp in.out LED off. And as the description says, switch the LED on and switch the LED off. Very easy, and that's something that we would like to use. So therefore I'm just saying okay, ewbsp in.out, and then I copy that. So going now back to my embedded wizard, going now into my toggle LED slot, which gets triggered by the toggle LED button, and inside the editor I'm just now pasting. So set control on the right mouse and said okay, let's paste my ewbsp in and out, and it was without any arguments, so that means just a very simple call now to this function. However, when I now press, for example, the play button here and start the prototyper, and I now would toggle that, then Embedded Wizard says call to an unknown method ewbsp in.out LED on. Of course, Embedded Wizard does not know your customized, your dedicated API. To cope with that, first of all, you need to say, okay, this statement that I'm having here, this one is now the so-called native statement. And with a native statement, Embedded Wizard simply says, okay, this one does not belong to myself, so not to Mosaic, not to any classes that are defined inside my GUI project. I'm just using that as it is, and transferring that to the native world. And as you remember, we are following the source code generation approach. That means this current native statement is now used entirely into or transferred into the C world. So let's, for example, have a look how it looks like inside the generated C code. To do that, going to the project, selecting the profile, and define where my proper output directory is. So where should I now generate the sources? And just remember, we had before mentioned the build environment, and there's the application, generate the code. If you're not familiar with that, please have a look at the previous session where everything is described properly. Okay, so selecting the output directory where now the generated sources should be copied to, and going now back to my build environment, inside the application, inside my source, generate the code, then you see that I have now my dedicated generated sources, and for example also my application.c. Application.c, just a small and short wrap up. Application C belongs now to the unit application, so every unit itself is transferred in a proper C file, and inside that we have a class application, and there we have the method toggle LED. So opening that, and as you can imagine, on the very low end, so before the class is finalized, it is there. So that means we have the unit application, we have the class application, and we have the method, the switch method, slot method, sorry, toggle LED. And in fact, as you can now see, EWBSP in out LED on is now called. Very easy, right? So, however, there's just one thing to keep in mind. When I'm now inside my embedded wizard project inside the studio and press again the play button and pressing now the button there in order to toggle the LED, it just says, okay, here the native statement is ignored during the prototyping. Why? Because the native statement contains target specific code and the prototyper is not able to interpret and execute that. In order to avoid this warning, you can just enclose the native statement between a pair of $if, $not prototyper, and if directions. And this is something that we are now doing. And this is now built in a macro functionality. We had that when I talked about the Cora languages of Embedded Wizard, one of our previous webinars as well. And there say, okay, if not $prototyper, then do this, and finally, and if and just closing that again. And with that prototyper, just pressing now play, you can now toggle the LED. No further warnings are popping up, only the traces comes now to the log window, but Embedded Wizard does not reclaim anything and says, okay, everything is fine, because it's now said that this one does not taken into account when the prototyper is started. However, it is taken into account, just regenerating the sources when I'm when I'm generating the sources to the C word. And as you can see, it's still there, EWBSP in out LED. So usually when we have now this environment, as I said, toggle LED, I need now to have some kind of variable in order to store my current setup for my LED state. And using that, I would suggest just to use a property, which is my LED property, something like that, and it comes not with an integer, so just changing the type to a boolean, defaulting to false, and this toggle LED should just say, okay, every time I'm now toggling the LED equals not LED. Just very simple one, just to flip and to toggle the LED state. However, that part should not be now taken into account into the slot method. I'm just now removing that by cutting that out, opening now the onSetLED property method there, removing that, and say, okay, if $not prototyper, then just execute that native statement. So, and in order to have some visual representative, I'd like to add a new view, just a very simple one, which is this small rectangle there, and this should be to green, something like that. And every time I'm setting my LED value on, I'd say, okay, this dot rectangle 1, I think, was the name. Yes, because the rectangle without the 1 is the black one in the background, and this should be visible equals to my value. So, however, just one thing to keep in mind, the LED is per default false, and in order to synchronize that, I'm also saying, okay, this is false. Very simple one. Good. So that means I'm here now the toggle LED. This one gets assigned to the property. The property is then invoking the onSet method. And when I'm now, perhaps just rename that, and every time I'm changing now the value, this simple methods gets invoked. So the visibility is flipped, as well as my native call is done. However, I need now to toggle, and toggling means that I also need to get a proper call another method, for example. How can I now do a propagation of the given of certain variables now to the underlying C word? And in that way, it's also very easy. that I say to the native statement, in fact, I'm now getting a variable, and this is my temp variable, just very easy one. And so for that, I say, okay, if temp is true, then I'm saying EWBSP in outlet on, or the other ways, I say, okay, and there I have just flipping the window to my header files. I say, okay, copy EWBSP in out LED off, which is then called instead. So very easy one. However, I now need to say, okay, this is my temp variable. What is that? In fact, we have now here a var boolean, and that boolean is of name temp, and this comes with my value. So that means every time I'm getting true, that the LED should be switched on, this one is evaluated, the LED method is called, or otherwise it's just off. So just test it. So let's see everything is working. When I'm now hitting the button, then you see the red rectangle pops up, and every time I'm now switching this on and off is now showing how this LED is behaving. And I think I also get the proper traces out there. Of course, you could also say, okay, toggle LED, not in that one, just removing that in order to have more overview, and say trace LED to my current given value. So I really can do some proper prototyping. So true and false and true and false. So very simple one. Okay, so let's generate the sources. And just double check that now in my generated sources, scrolling down a little bit, then you see that I have now here my onset LED slot method with the proper implementation of invoking my BSP function that way, which could be, in your case, your middleware call to your business logic. So this one is that. However, now let's go to the target, and how does this now work on the target. And to do that, just minimizing that window, minimizing that as well, I'm here already inside my build environment, and invoking now the build environment, I need to have some make system, and as you can remember, this is something that we deploy out of the box, so very easy one. So now invoking make, invoking the compiler, and as you probably might see right now, is that I've got a proper warning from my compiler. So for that, I'm just now interrupting that, which says there is now an implicit declaration of my function EWBSP in out LED on and off. Of course, when you just have a look in the generated sources, there's the call to my EWBSP in out LED on off function, which is defined in EWBSP in out.h file. However, as you probably might see when looking at the include files, it's not included, and that's the reason why now the compiler says that, or just puts out this warning that this is now an implicit declaration, and that this will probably not work. So how to add this proper include? Of course, you could now do inside the generated code and say, okay, include EWBSP in out.h and save it, and when just now invoking the compiler again using make, then you see now the application.c is generated in the proper way. However, the drawback is, and this is something that you should then not do, when you just now regenerate the sources again, and it could be that it's not generated because there's no change, so just hold on. So every time you're now regenerating the sources, then you see that inside my application.c, so the generated application.c, this currently added include statement is removed. So every time the sources are generated, it's removed. So how to deal with that? And there's just a very easy way to do that. Going now into my unit, and inside that unit, there you can add from the Cora gallery the so-called inline code. Drag and drop that, and saying, okay, this is something that also needs now to be generated into my unit, and this is just a functionality which is provided inside the core language, the inline statement. And there I said, okay, this is just my simple include ewbsp in out.h file. So what's happening now? Regenerating now the sources, looking now at the generated sources, then you see, okay, there is no include statement, but just scrolling down a little bit, then you see it, there's now the user-defined inline code, application inline, include ewbsp in out. So now it's there, but it's at the wrong place. How to cope with that? In fact, just remember, inside Embedded Wizard, everything, or mostly everything, is related to the Z ordering, and so also the order how things are generated into the C application. In fact, we have now the definition of the class, and you see it's set ordering at the bottom. Then we have a node, we have the font, and now we have the inline. And as you can imagine, when I'm now restacking that to the topmost, to the backmost position, so at the bottom, then Embedded Wizard takes that into account as well and generates that as the first statement. So going back now into my application.c, then you see, okay, there is now not the include statement anymore at the bottom of the file, but scrolling up, then you see that here comes the previous one, which belongs to the generated one, which is automatically generated due to the dependency of Embedded Wizard. There are the constant definitions of the strings, etc. And then we have our user-defined inline code. And this is now something that is essential to keep in mind when you add your dedicated middleware APIs, when you define that you do not forget to put the proper Z ordering of your inline statement in order to have that include file. So going now back to the application, just type in make clean so that everything is tidied up in a proper way, and hit make. So it's now enabled and compiled by the GCC in that case. And by the way, the build environment, the make files are already set up that my used ewbsp in out, where is it, there, is already added to the make file. So there's a static element there. It's not being generated by Embedded Wizard. It's static one, and it's already there. Hence the linker does not complain and does not put any errors on the console that is not working. So because already set inside the make file that this proper correspondent module, the ewbsp in out.c, is already also compiled and used then later on when it comes to linking the application. So we have now the application, and as you can imagine, I now just want to hit make install. So now the setup is pushed to my application, and when this is done, I just like to open okay, that's fine. I'd like to open a small browser because I have their webcam, and let's say for browser, and here we go. So this one is now the RT1050 board, as you can see, and unfortunately at the bottom there we have some small LED out there, and by toggling it on and off, then you see that when I'm hitting, it's not so easy, then you see probably that this LED here starts blinking. I hope you see that every time I'm touching. Okay, so I think for the touch it's not so a good choice to have that, so therefore just minimizing that, going back to the application, I'd like to do some automatically environment, and therefore what I'm now doing is just put an if effect there, a very simple change Boolean effect, and the Boolean effect should be first of all enabled, So it's true, and the outlet is my LED, and to do that should now flash the LED in 1 second time interval, but this could be a little bit easier. Let's say, I don't know, 250 milliseconds, and starting again, then you see it's there, and also increase that intercycle delay, and just testing that. Yeah, so now we have a proper blinking of the LED itself. So, and that means when I regenerate the sources, going now to my console, invoking the compiler, the linker, and finally flashing the device, should now give you, hold on, it's still flashing. Yeah, so, and you see that in full screen, and then you see that this one, the small LED here, is now flashing in these 250 milliseconds raster, which is now driven by Embedded Wizard. So, and you see it's also corresponding in a proper way on the GUI itself. Okay. Let's now have just a further look into this native statement here. As you can see, we've just given a proper variable, which is assigned of this value by this onset LED slot method. The question is, how can you now, for example, pass some values back now into Embedded Wizard? Unfortunately, as far as I remember, this function EWBSP in out LED on or off is just a simple void method. So we do not have any return value. But for example, let's assume we would have one. Let's say, okay, this EWBSP in outlet function gives back some variable, and for example, we have some car result equals to 0, and depending on this function here, we're getting that back. The same one, of course, for that. So how would you now get back this result there? In fact, it's very simple, and you just pass by another variable there. For that, I'm just now copy and paste that, so that way, and I say, okay, this is my result. Oops, sorry, my result, and that result is also passed to my native statement, and in fact my result that I got back, something like that, is result equals res. Of course, you could now just omit that character result, etc. However, let's have a look at generate the code. So back again here inside the application.c, scrolling down, and then you see it's very easy. At the end, we have now here our result value, and it's just assigned, and of course later on you would get back or could use that return value in a proper way. So let's just close the gap. So that means a very simple one. Let's trace something like that, result equals result. And how does this look like? Going back now to my editor, which then just say, okay, here's just a result. So it's very, very easy to define here the proper variables. With native statement, you can pass variables now that are used inside your middleware. You can pass any parameters back from the underlying C world and use it then later on inside Embedded Wizard. So this is just very easy. However, something to keep in mind is all the different aspects for conversion. As you see, we have here an X-bool, and how is this X-bool now transferred from the C world to the Embedded Wizard's Cora world, and vice versa. And as mentioned a couple of times, meanwhile, please have a look at our knowledge base, and there you find a section called device integration, and this explains everything what I'm now doing or have now done in a proper way, and gives you also further hints how to do a proper conversion of different types to other types and how this is done. Yeah, so this is for the native statement. However, with a native statement, I've done now a very simple way. We have this property, and that property switches on the LED, switches off the LED. Is just one-way direction. Of course, with that result variables here that you can pass to the native statement, you would also get now proper return values. Of course, you could also give result one additional or further variables there, something like that, blah blah blah. This would work as well. So it's not limited here with a native statement with a dedicated number of arguments. However, as you see, this is just a way now from the embedded wizard world down to the C world. The next question that usually pops up is, how do I do this in the other way? What happens when I have some event or some asynchronous stuff happening in my system inside my middleware? How do I pass that data now from the C world up to the embedded wizard world? And as always, there are multiple ways to do that. An easy way would be, you have a timer, something like what I'm here on effect, and I'm setting, every 100 millisecond, I'm just asking my middleware for new data and propagate that now to the system. Some very classical polling approach. However, depending on your API that you're defining by yourself, it could be that this polling approach is not the best choice. Just imagine you have not only one property that needs to get polled, and it's easy to go, but what happens if you have 10, 100, 500 thousands of properties that are lurking around in the system, and you need to get notified by an event when this happens. So a classical asynchronous approach, a classical message-based approach, or event-based approach. Of course, you could poll that, but this is something that I would then not recommend when you have multiple properties or events in the system and they change during time. So how to do that? In fact, it's something very similar. You would generate a API. So let's, for example, do that. Going back now to the application, just removing that a little bit, and let's define a new unit, a new class, and this one would be my LED class. Let's say that one, and with a small L, please. Okay, and that LED class, just opening that, have now the property. Now let's, for example, take that property that we have already here and just remove that out, so cut it out, and going to the LED, paste it, and move that there. Of course, it should not be LED. Let's say, for example, because I'm already in the LED class, it is my state, something like that. So, of course, we should now do something like that. This rectangle here doesn't make much sense because we don't have it, and we also, as you remember, the API does not foresee to have a return value. So for that, I'm just now removing that in order to make it compile clean, and just removing the things that we just did before. And of course, there is no result, and this one as well. Sorry, this was wrong. So there as well, and just tidy up a little bit. Okay, so the classical one, we have the state. If the state changes per default, then I'm just now doing a trace. I think that's fine. And at the end, we're just now calling that. So this is the LED. Going back into the application, now I need to tidy up a little bit as well. So we have here this outlet, just removing that right now, reloading, and now it's working. I think in the slot as well. So we have here also now the reference to my LED. So of course I do not now have it. In order to do that, in order to have now access to my LED class, I'm just now going to my browser, search for my LED class, and simply make an object out of that with the name LED. It's now an object of my class with a dedicated properties, and I would now have to have certain different properties and other things. So perhaps let's just rearrange that a little bit. So you could have multiple different properties, all with the same functionality, or not with the same functionality, sorry, with different functionalities. For example, if you have a motor, you could enable, disable that, you could change the RPM, etc. So very depending on your application, depending on your appliance at the end. So now I've got an object of my LED, and inside my toggle LED, I could also say LED.state equals LED.state in the same way. So just testing that. It's testing, but I'm not seeing my bool effect because I have dismissed that for the outlet, and I would say my LED.state, the reference to that, pressing on the play button, and it should not work. So why is it working? Have a look at the debug. Now it says there, because my boolean is false, and that's true. The LED is there, it's also false, and the state is working as expected. And what's the reason why my toggle stuff is not working? Because that's false. False. It should now blink. No, it's not blinking. Now this happens during live coding, so sorry for that. Just looking where my issue is. So I have the LED state. This one goes to LED state. This is the LED state. It is false. It says if pure state value toggle LED, and what does this say? It says it's toggling. Sorry. Yeah. Why does this now not work? Because I have just removed now inside the property here that my my rectangle isn't working. Just remember, and of course I should say, for example, this rectangle 1, so the green one, visible equals LED.state. So I think that's the proper one. So sorry for that. No. So this is nice. False LED rectangle 1. And now I have an issue. No. Oh. Clear. I'm changing the outlet of the LED property, and I'm not changing the slot method. So what I need to do is not to define the proper outlet. I would now add another property, and of course that property would then invoke the slot. So nevertheless, forget about that. Sorry for that. So back again in the LED class, we have different kind of properties. You can then go back now into the C world. So the question was, how do we now propagate up again the information that you received from the underlying system. Just one further thing before I can answer that question is I have now this object of my LED. Usually inside your appliance, inside your device, you would have one entry to your middleware or to your GPOs or whatsoever. It's just one instance. And when talking about only one instance at the end, then you would need to have some kind of singleton. Singleton means you need to have access to just one instance of an object, and how to do that. Remember perhaps also some previous webinar sessions that we did talking about Cora. There was the functionality of the so-called auto object. Auto object, as the name implies, is something like a singleton. It gets instantiated automatically every time you have a dedicated access to that. And for having that, it would say, okay, inside my unit, where's my LED class? I just make a copy, and I'm just doing an instance paste, which gives me here now this auto object of my LED, and I'm just renaming that to LED itself. And now you can use that inside, of course, your application as well after changing this one. So this one would now go to my LED state of my application, for example, and here in the same way, but as we know that this is not working, sorry for that again, just commenting that out, would now have the same effect. However, when now, going back to the generated sources, then you would see, okay, this is my function, my property function that is there. Of course, and this is now the proper answer to the question how to invoke things back again. We are following the principle. You have the unit, you have the class, you have the method, and this is the same that can be added now the other way up again. So going to the application, going to my LED, and having some kind of a method which would say this is my update method, which gives me dedicated arguments. For example, now I'm just having this arg1 with a proper return value. That's it. So this would be now the method that should be called now from the underlying system, generating the sources and having a look at that, which now gives me my class, my LED class, and I have here this onSet property and this onGet with the proper functionality to my middleware, in that case EWBSP, in out LED on off, etc. But something that you probably now might miss is this function of this update method. When having a close look at the generated sources, then you see that here I have now this application class with a constructor, with a destructor, which is here the done. It's the onSet state, it's the onGet state, but something which is missing, because as you see, EW define class and end of class, which just says, okay, this is now the LED class is now proper defined, and that's it. So nothing will then pop up. We only have here now the auto object, but that's it. So you see that this update method itself is not generated. And if you would now want to call that functionality from the C world, then you need to tell Embedded Wizard, hey, there is the function that I'm calling now not inside Embedded Wizard. I'm now calling that inside my C layer and in my underlying BSP layer. So Embedded Wizard is very smart, and it analyzes the GUI project when generating the sources. And during that analyzation, it finds that there is no reference inside my UI project that uses that update method in a proper way. And as a result, it gets simply eliminated. It's dismissed from the source code generation process. It's not there anymore. But as a side effect, you cannot use that from your C word. So how to cope with that? There's just a very simple attribute when selecting that method here, which says this one is generator false. And as the documentation already implies, says, okay, the code generation attribute determines how the selected member is handled by the code generator. In fact, it's now false. Otherwise, if there would be some reference, then it is taken into account. Just for example, going here to my onSet method, and let's say, okay, update method with 1, something like that. Generating again, and then you would see that inside my application generate code that there's now the update method. Of course, because now it's referenced by this set method here, by this onSet state method here, by this property method. So, but it doesn't make much sense now to really use that, and therefore there's a proper attribute determining how this method is then generated. So when I'm now doing something like that, I say, okay, it's true. And by the way, you see, you can also determine, depending on your proper profile, if this one is generated or not, but let's assume it should be generated all the time. Pressing again this button here to let Embedded Wizard generate the sources again. Going back now to my application, and then you see there's no reference anymore, but at the end, Embedded Wizard says, okay, it has been generated. But you should use that, which is the proper wrapper class for the non-virtual method. So this is something which then is important to know when invoking now the methods. So what you could now do inside your middleware, you can include application.h file. There is the method application LED class update method, and as these arguments tell you, it needs this pointer, which belongs to the object, and the proper argument that we have defined previously inside this update method there. For example, would you now double click on that, and say, okay, insert a new integer 32 a arg number 2, something like that. Then you have a second argument, generating sources again, and then going back to the generated sources would then simply add the additional argument for that. And this is something which can be used. So remember things that we mentioned before. Embedded Wizard follows your API, but that implies that you need to define your API inside Embedded Wizard. So we have methods that can be called now from the underlying C world. There are methods that can, or properties in that way, can be used to trigger certain properties to the underlying world, and everything is possible. However, now you might ask, is that really necessary? Unfortunately, I need to tell you, yes, it is. And this, as we call it, binding, is something that needs to be done in order to talk to your system. However, some advantages, now going back to the unit application, is that you probably might know from this device gallery tab, this entry here in this device gallery. And as you can see, there is something like the so-called device interface. What I'm now doing is just drag and drop now this device interface into my composer window, and it already gives you further information what this is all about. As you can see, it looks very similar to the things that we did before. It's a device class. In our case, it was LED class. It is then automatically an instance of that device class, which is now the device auto object, the same one as we did before with the LED. And by opening that, gives you now something already to be used. In fact, we have a property, just switching back to the LED, we have here a state property with onSet onGet method. This is something which is similar, also available inside this device class, which is the template that is available inside the gallery. And in the same way that we did before in the LED class, there's also a method which can be used from the underlying C world. Remember the generated true inside this update property that we also have here, and which can be used from the underlying C world in order to update the property. And as you can see, also the generator attribute is set to true. Something important to know, I'm pretty sure I have mentioned that in one of our previous section about the Cora languages, is the observer pattern. And as you can see, all this update property method, which is invoked by the underlying system, by the C layer, says, okay, if there's a new property, I'm now also calling this notify observer property in a proper way. And with doing that, you could then add proper an observer which listens on changes of that property change here and reacts on changes in an asynchronous way. And this is something that we can also do now with this property observer. So going back, for example, now to this to my application, and drag and drop a property observer, and this is now something which is also an object, and it simply tells you, okay, on which outlet I'm now listening for any changes. And in fact, I would now also have the possibility to hook into my LED state, my predefined one, or in the same way that I did before with with the device property, which is defined now through this template as found inside the gallery here. And I'm simply saying, okay, every time I'm changing, please send a signal to this on event method, and you could now react whatever you would like to do. So this is for the property observer. Another way, but this one belongs to a property. So if a dedicated property changes, then you would call from the underlying C word this update property method, which changes the property and emits a signal and notifies all attached observers in order to notify that this property has been changed. So this is all the mechanics behind. Another type would be if you have a more global event popping up. You have, for example, a power failure, or I don't know, battery goes low, something like that, and you need to emit a warning to your GUI. But this is more something which is a global event, a system event, and that system event is more or less managed in the same way. Yeah, you would have here this trigger event, double clicking on that, which then says, okay, there's now another object, system event, and this gets triggered with a proper attribute. If you want to add for example, the context of this event, let's say you have a power failure and the power is only now 5% of your battery, then you would add a dedicated object which comes now with a context, say 5% power left, to that system event. And in the same way, you could then also add your system event handler inside your application in the same way, which says, okay, my system event handler, this listen on changes now in my system event from my, in that way, device application. So this is all about there. Sorry for that. Finally, a very primitive way is just invoking a command, and this is something that I already did before with my LED, what I have done in my slot method. As you find there, if prototyper, do nothing. The other way, so if not prototyper, then you see some results, and then you see the native statement with the parameters, the result value, and then you can do whatever you would like to do in a very simple way. So this is all there. It's a template, the device interface, you can use that. However, this device interface is now very abstract. As said before, and as already seen, I have also a proper example available in my build environment, which says device integration. When I'm just opening, sorry for that, opening now this application. Yes, save it. Yes, save it in my Embedded Wizard Studio. And as you see, there's also now a device class. You have here the inline, which opens some additional header files, and there's now this device interface at the end, which comes now for this evaluation board with very simple stuff. It's the same way. It's an LED status with a property, and as you see, it's then there the onSet method, which simply invokes another API call. It comes with proper trigger events, and it also gives you an information if some properties have been changed. Very easy one. And how does this application look like? Just to give you an idea. When you have here the play button, then you can toggle on and off the LED in the same way that we did before. We have this print hello world, which would simply print out a string to the console, to the serial output, to the UART, and give some feedback on that. And finally, there is a hard button event, which gets indicated when a hard button is pressed. So this is for the device interface that you see also with the dedicated event handlers. For example, in that way, if there's a hard button or if there is a property changing, in that way it's a hard button counter observer. When that has changed, it gets signaled and notified. And Embedded Wizard is then reacting. For example, that status bar is then increasing and shows the current counter of how long this hard button has been pressed. So perhaps now it's a good idea to show you how this works in real life. Going now to my unit, typing in make. By the way, I do not need now to define the output directory. It's already predefined as it is an example as found inside this build environment. But I'm not sure if I mentioned that before, although it's now running for the NXP environment. This is something which is more or less the same through all our other platform packages and build environments that can be found on the website. So maybe for ST, maybe for the Raspberry Pi, etc. So this is all there. It's standardized from our point of view, and this one can be very easily ported to other platforms as well. It's just now using this platform here, as I have this here available at my desk. So you want to see how this looks like, of course. So going back to my browser there and opening again the webcam. Say we have here the full screen so you see that. So in fact it's the same. We have LED state, and in fact here the LED is on, respectively now the LED is off, and what you see is here's a hard button that can be used for the UI, and when I'm switching back the UI and I'm now pressing the UI, then the button, then you see that the UI reacts accordingly. So every time I'm now pressing the button. So, but how is this now done from the C word? I'm just closing that. And for doing that, we are now having a look at the so-called device driver.c implementation. Device driver itself, as the name implies, and what I mentioned before, is now a driver at a certain point in time now for dedicated peripherals. In our way, it's now the LED and the button and the UART, and this is something which is there. We need to initialize this one, and this one is done. Perhaps you remember that last time inside our EW main.c, where the device driver is initialized, and in order to let it work, there's now the EW BSP init LED as well as init button with a proper callback function to an interrupt service routine. So, and now the next thing, these are now the more important ones. So this is just for initialization. Going back now to the application that we have here, inside our application, we have this device class and we have the auto object. Remember, last time or inside the core session, I mentioned that the auto object gets initiated when there's an access from the GUI perspective. However, if there's no reference anymore, then the garbage collector sees that and removes that from the memory in order to save memory and to tidy up and free all the unused resources. So, but what happens now if I'm now pressing the hard button and this device object is not available anymore because the garbage collector does not see any reference and hence it is removed. And this is something that should be avoided. To do that, first of all, I'm now getting an instance to my auto object now from the C word, and there's a dedicated API called embedded wizard get auto object with my proper application device and the proper application device class. So this is how embedded wizard is structured or generated the sources in that way, and it's assigned to my reference to my object. And as just said, I now need to take care that the garbage collector doesn't remove that, and this can be achieved from the C world by simply locking that currently or just received object with this API call EW lock object to my proper reference. And then I have access to my global assigned device object. I think it should be static somehow. There is it. Here's my static application device class, my device object. Now it's null, but after initialization it is assigned with a proper reference. The pointer to my auto object, it is locked, so the garbage collector will not remove it anymore. Of course, deinitialization, please ensure that you then after the device driver is deinitialized, you will unlock the property object in a proper way so that the garbage collector can then remove that later on. So what's now happening with the LED status? I think it's more or less the same what we just implemented before. Get some value, and depending on that evaluation, switching on the LED or off, encapsulated with my own API device driver set LED status. Very simple. So, and the other one is just printing out a message to the UART with EW print. I think that's not something very it's not very complex, and here for the set time is just now for the RTC, but this is not important right now. However, something which is important is when you just have a look at the initialization of my hard button that I just showed you. In fact, in our EWBSP init button, I'm assigning also a proper interrupt service routine, which is now a callback. In that way, the hard button ISR callback function. And this function, as shown here, is then called by the interrupt. And as you know, during the interrupt service routine, you should not do any intense methods and algorithms. You should just store the flag and release that interrupt, so it then moves on with a proper CPU calculation, etc. And this is also now here the case. So in fact, if that button is pressed, so the ISR is called by invoked by the interrupt, that happens when the button is pressed. Then I'm just saying, okay, if this button is pressed, I'm just storing that, so it's pressed and it's down. Otherwise, I'm just releasing that. Very very simple way. And now I have this information in my static variable. So now I need to put that into the UI layer. And the most important method that is used is now this process data. And perhaps you remember, or we can just open that in our EW main.c. When looking at the main routine that is called periodically in this EW process function, then there's at the very first beginning the function device driver process data. And in fact, the most important thing is that it returns, or the result value of the process data is inside the devices, which is then later on evaluate if there is something now to be done inside the GUI. And you see that inside this if statement here, if my devices, so if that value is given, then at the end I need to take care about updating the GUI, updating the memory, release memory, etc., depending on what should be done. However, this should be done in a periodic way so that the UI knows that that might be some updates required, emitting any signals or sending a signal whatsoever. So inside that device driver, so the counterpart on that, the process data, it just says, okay, is there now need an update in order to be done, and now it's evaluating if that variable is true or false. And if this hard button down is pressed, I'm just now only increasing this button counter. But something more important is if my hard button is pressed, I'm now invoking a simple function. And named by convention, unit, application, device class, that's how the class is named, trigger hard button event with my previously get auto object from the initialization routine, and I'm just now triggering a proper information. And in that way, I said, okay, now I need an update. It's asynchronous. It happens. So embedded user needs to take care that this one is pressed. And of course, I'm now just releasing that. So in case I'm just pressing it again, it goes back. So in fact, this one is processed periodically. And if this if the previously called interrupt service routine defines that variable to true, I'm just invoking that function. Application device class trigger hard button event. Going back there, it simply says the device class trigger hard button event. Double click on that. It says, okay, this is now my hard button event, which is a system event, which can also be found now here inside my device gallery. You could add another system event with a proper function, for example, like that. Of course, it's renamed in order to match the proper environment. Just removing that. And finally, it's then put into the system. And everywhere where you now are, going back now to this application, for example, you could then add a dedicated system event handler. And you define, okay, on what event you should listen. For example, our hard button event there, and this on event method gets then triggered and do whatever you would like to do. In our way, just opening now here this on hard button event, it just say, okay, here's the bool effect, which starts blinking the sign here, and that's it. A very very easy one. So not something very complex. But this is now the methodology to react in an asynchronous way on system events, and of course it could be the same for Just removing that for any properties in the same way. Just looking at that, we have here the update hard button counter. It's the same one. I have here a reference to my device class, in fact my device object, so the auto object. I'm assigning a dedicated value to that, the current counter, and that counter is then used inside my slot method, where I can now access my device hard button counter and use it as a string, which is then used inside this text view for that. So just looking now at the watch, I think I have mentioned now everything which is essential. However, just going now back, and I really encourage you to go to our website, Working with Embedded Wizard, and then you see that everything is explained in a proper way. So integrating with the device, this is all about the native state. For example, started in the beginning, the inline statement, invoking the GUI application code from the device. Think about the generator aspect. This is mentioned there, and how this conversation is done. And finally, I'm doing now this inside the device interface is something very similar, where you have the auto object with a proper device, and how to use system events, for example, how to use the different property with a proper property observer, how to invoke that. This is all mentioned there, and for every hardware that we're supporting within our build environments, there are the proper examples available, as you can see here inside this brick here the device integration example. So that's for now. Just now going back to my slide. Thank you for that. I hope I could shed some lights on that and demystify the thing, how to exchange data from the embedded wizard world to the underlying system. Of course, something important, sorry for just jumping, is especially when scrolling down, is the thing how to do with strings. This is not so easy as of now, because you need also to allocate a proper string, and Embedded Wizard itself is dealing with Unicode and not with ANSI C strings, so it's a little bit more complex to take into account, but therefore we provide dedicated helper functions, EW string to ANSI or string to UTF-8, etc. Or when you want to create a new string, EW new string or new string from ANSI, etc., which can be used in order to create strings during runtime on the C world. So this is something important to know. The same applies for arrays. Array access is also a little bit tricky, I would say. But let's I encourage you to get inspired how arrays are managed inside Embedded Wizard, and for proper exchange, and this is all documented with a proper example and easy to understand, but it's a little bit more complex, so I'd like not to put their focus by today, just having a look at that. So sorry for jumping, going now back. Thank you very much for your time. Really appreciate that you spent some time with this not so easy topic, and now I'm very happy to listen and hopefully to give you proper answers according to your questions. Christine, are there any questions lurking around that I could answer right now?
Great, good. So now let's come to the question and answers part. And I already have a first one, which I want to ask you, Manuel. How to set up Embedded Wizard in a multi-threading environment. Anything I need to know about this?
Oh yeah, multi-threading, multitasking. This is, very, very easy to say. In fact, when just going now to the device drive, for example, where I'm now calling this API function of my generated sources, so the application, device class, update hard button, counter, for example. Embedded Wizard itself is not thread safe. It is not task safe, so that means if you would call that function from another thread, you need to ensure that this one gets synchronized with the proper main loop. So in fact, something that then I would suggest inside our EW main.c, for example, before doing the data, or especially before doing any processing the timers, you would define a proper mutex or semaphore and wait for that, so that you can then call your environment in a proper way. Inside the device driver. Putting here a mutex, wait for the mutex in that way, and so that it gets synchronized. However, you could also do something different when working with an event queue. So you would push, and this is something that's usually available when working then with operating systems or real-time operating systems, that you would then push the data or enqueue the data to an event queue and inside that main loop, and this could then usually be from another thread, from another task, and inside that main loop, or in our way the device driver, you will then get out the event. You would pull the event, react on the event, and if required, then push it to the embedded wizard world. But important to know, and I think this is also mentioned inside the device driver device integration section here, avoid multi-threading. Embedded wizard is not thread safe. Never, never, never call an embedded wizard function from a foreign thread or task. Important to know. Yeah, I hope that clarifies this question.
Thank you. So here's a second question for you, Manuel. Can I also not only exchange pure data, I want to display my own rendered graphics? What do you say to this question?
Yeah, so the device interface, device class, this is mainly for really exchanging data. However, Embedded Wizard is very flexible and does not only rely on this kind of data exchange. Inside Embedded Wizard, when going now to the studio, for example, and for the resources, then you find a so-called extern bitmap, and this says runtime loadable image file depending on your implementation. However, this is just now inside the gallery that can be used, but a more and detailed information how this can be done is found also on the knowledge base, extern bitmap interface, how this can be achieved. In fact, with that extern bitmap, we're providing only an interface, not an implementation, depending on your environment. And with that, you can, for example, do loading of decoded images from SD card, for example, or from received from the internet or whatsoever, or completely different. However, the techniques in order to maintain metadata, for example, and transfer things, EW string to ANSI, for example, is something which is then of course used by the other system. But for dealing with graphics, please have a look at the so-called extern bitmap interface, which is more for static environment. Of course, you could also then integrate, for example, other components which are rendering graphics more dynamically. Think about a web browser, for example, or think about a image decoder which gives you a video stream at the end, something like that. And to do that, there's also another example, but more or less following the same technique. Going back to Embedded Wizard, inside the project, open example, and then we have the so-called where is it? The so-called applet application, and that applet application is something like a game, like a navigation software whatsoever, which can then be used more dynamically. And that way, this application is just drawing this small dot here, and which removes a simple game implementation, and this one removes moves this dot here depending on the user input. This is all documented inside the application applet, and this uses the so-called applet View, View's applet, which is also then implementation and describes more detail inside the documentation when it comes more to dynamic environment. But this more is for frequent loading of images, so like navigation software, for example. However, when it comes more to static images, then please have a look at the so-called external bitmap interface, which gives more information in this particular question and demand for integrating more static images during runtime into an embedded wizard GUI.
Thank you. And a third question is there a possibility to use my middleware already in the studio? Wants to know one of our attendees.
Oh yeah, that's a really brilliant question. In fact, our credo is really to simplify the GUI development. And as you can imagine, if you have now your middleware defined here in the C world and bringing that to the target and see how it works is not something which is very enhancing and beneficial for the development process. Our aim is really to shorten that, and in order to achieve that, so that means in order to bring your middleware into the studio already during development time, is the so-called intrinsic functionality. Intrinsic functionality is something like a Windows DLL file that gets loaded dynamically inside the studio, so maybe for the prototyper, maybe inside the composer, and can be used then during development time. But as the name implies, or what I just mentioned before, it can only work if you have your middleware working as in Windows DLL. And to achieve that, it's also well documented how to implement this kind of intrinsic modules studio project, how to do that, how the DLL should look like, etc., and how at the end dedicated functions should be made available to the C world, how data type conversion is done, and as an example, a very simple example how to for example open some files from your Windows file. But this is just an example and can be used as a reference. So this is all there. It's very well documented, and with that intrinsic module, as said, a DLL, and you can bring your own API already inside the studio and then program against your middleware already during development time, which it gives you a proper, very nice feature, really to shorten, to simplify the overall GUI development a lot. So that's for now. Thank you very much for all of your time. If I couldn't manage to answer all the questions, please send us a mail. And thank you very much again. Highly appreciate it. And looking forward to hearing you soon. And from my side, I'd like to say goodbye. Thank you very much. And stay healthy. Take care. Bye.
Thank you, Manuel. Okay, we're coming to an end of the 6th episode. I want to give you the following information concerning our next webinars. We will be taking a short break now for some weeks. This is also for you to recover some content and for us to prepare for the next series. We will be back in a couple of weeks here again with our Masterclass Mondays. So don't get surprised when this session closes. There won't be a poll about the topic to be covered next week. But still, we will be happy about receiving your feedback and getting your questions also afterwards, after this webinar closes. So take care and bye-bye for now.